Okay, page 2. Here we want to clear the fractions. We have an equal sign. If we were getting a common denominator, it would be 10x. So that is what we're going to multiply both sides by. If I take that fraction times 10x, I just get 5. And 5 times 1 is 5. If I take this fraction times 10x, I get 2x times 3, which is 6x. And if I take this fraction times 10x, I just get 7. So 6x plus 5 equals 7. Subtract 5. X equals 2 over 6, which equals 3. We have an equal sign. We want to clear the fractions. This factor to x minus 5. So that's what we're going to multiply by. It'll work out. When I take this fraction times that, the x minus 5's cancel, and I get 7 times x. When I take this fraction times that, everything cancels, and I just get 4. And this fraction times that, the x's cancel, and I have 3 times x minus 5. So now, no more fractions. We finish it out. I have a 4x here. I have a negative 11 here. Negative 11 over 4. All right, these here. Remember, step 1, make them equal. Then solve. Then graph solutions and undefined values. And then check the regions. So I'm going to say the absolute value of x plus 5 equals 11. Now to solve, I have to get rid of the absolute value, so I need to make two cases. I changed the sign of the 11, not the plus 5. So here I get x equal to 6. Here I get x equal to negative 16. I'll put those on a number line. If I check a number like 8, I get 13 less than 11. That is not true. If I check a number like 0, I get 5 less than 11. That is true. And if I check like negative 20, I get 15 less than 11. Not true. So it is these numbers here would be my graph, and in interval notation, it would look like this, parentheses, because we're not including the endpoints. Make this one equals. Now to solve, I get two answers, plus or minus the square root of 10. Put those on a number line. And then check. If I sub in 3 or 4 over here, 16 minus 10 is greater than 0. So this checks. Sub in 0 in the original problem, false statement. Sub in negative 4, you get 16 minus 10. These should be closed dots. And in interval notation, it would look like that. Once again, make this equals. Factor x plus 5 times x minus 2. So if I set that equal to 0, I get negative 5. If I set that equal to 0, I get 2. Graph. If I sub in 3, I get 9 plus 9 minus 10. That is not less than 0. If I sub in 0, I get 0 plus 0 minus 10. That is less than 0. If I sub in negative 6, I get 36 minus 18 minus 10. That is not less than 0. And there is the interval notation. Solving these, we want to work backwards. So I want to add 5. Divide by 2. If they take the square root, we square. Now I subtract 7 and divide by 3. Here I want to add 3. then divide by 4 to the 3/5 equals 10. Now how do I get x? I have to raise the left side to the 5/3 power. If I raise the left side to the 5/3 power, I have to raise the right side to the 5/3 power. Here I want to get rid of the 5 first. So I have 48. If I divide by 6, I have the absolute value of 2x plus 3 equals 8. Now I make two cases, equals 8, or it equals -8. If I solve this one, I get 2x equal to 5, x equal to 5 over 2. If I solve this one, 2x equals -11, x equals -11 over 2. This slope is clearly -5/4. So if it's perpendicular, the slope will be 4 over 5. This slope is -8 over -3 is 8/3. So if parallel, it will also be 8/3. And this one here, you could use the point slope form. Y plus 3 equals 3/5 times x minus 6. Then you get 5y plus 15 equals 3x minus 18. You get -3x plus 5y equals, if I subtract 15, I get -33. And then if I multiply by -1, 3x minus 5y equals 33. Or, because the slope is 3/5, we knew the left side of our standard form should have been that. And then if I put 6 in for x and -3 in for y, the left side gives me 33, so the right side would have to give me 33. Make equals. Subtract 2. Get a proportion. Finish this, solve it. We get 7. So on our number line, we're putting 7. And we're also putting 5 because we could not sub in 5. And now if we check the regions, right, over here it does not work. Here it does work. Here it does not work. So have this, this. The 5 does not work, but the 7 will.